All right, hello, Loa Nation. This is Colonel Greg Lowe coming to you from Tinker Air Force Base. It's wonderful to see you all virtually here online, and I'm proud to present what I call the depot. And this is really about the sustainment enterprise that supports all of our field units across the Air Force. So if we'll go to the next slide, this is what I'm going to talk about today. It's largely organizational, to make you understand how Air Force Materiel Command and really the Air Force Sustainment Center is organized. But we want to talk about the functions that we do, and then perhaps most importantly, I want to talk about how we do it, again, in support of the field units across the Air Force. So if you go to the next slide, just a quick note about me. That's me and my family. I changed command here at the 76th Aircraft Maintenance Group about 1.5 years ago. I'll be honest with you, this was my first real assignment in the depots. I had visited once as lieutenant. I did some supply chain work at an ALC, but never was really on the depot maintenance side. I'm a career migrant aircraft worker, having done mostly field level fighter assignments and a little bit of supply chain, some acquisitions, and some whole mill thrown in there for good measure. I'm a 2003 graduate of Amos, and then I had the opportunity to return back about a decade later as the commandant. So again, I considered myself a pretty tactically focused maintenance airman, and was very surprised to get an assignment as a group commander here in one of the 3 air logistics complexes. But I've learned an immense amount just in the short time I've been here. And what I'm hoping through this briefing is to share with all of you, whether you're a lieutenant or a captain, or maybe even a colonel who has not had the chance to serve in the depot, an understanding of what goes on here. And I know that I did, and I'm sure many of you do, kind of think nebulously of the depots or Tinker or Warner Robins or Ogden, and you really don't understand the organizational structure therein. And I'm going to help you understand those today. But what I'll leave you with, and certainly a promise here at Oklahoma City, and I know my peers out at Ogden and Warner Robins feel the same way, if you need something from the Sustainment Center, reach out to us and we'll help you navigate these kind of weird waters here in these huge depots at the Sustainment Center and get the right thing out to you in the field. Next slide, please. Okay, so I always like to start off with this slide. It's the proverbial top of the iceberg. And go ahead and advance to the next, the fill-in. These are the functions that I used to think about when I thought logistics. I thought functionally at the field level, things that we know, and it almost goes organizationally. You know, aircraft maintenance, supply, munitions, logistics plans, POL. Those things that you can reach out and touch and see at a base unit. It really wasn't until I got here to the Air Force Sustainment Center that I understood that there is so much more that goes on to make those base level functions successful. So go to the next slide. And this is the below the line. This is all that stuff that supports you, some of which you may not even be aware of. And I'll just touch on a few, like war reserve material. What's that stuff that you use when you show up for a combat deployment? How does it get to that location? How is it planned to be there? Aircraft battle damage repair. What happens when my aircraft gets shot up? DLA. What does the Defense Logistics Agency provide for me? Supply chain operations wing, supply chain management wing. What are they and what do they do? And frankly, what's the difference between the two? What's a software mechanic? We'll talk about all these things here over the next 40 minutes or so. And then I'll be online for the day of the Lowe University to answer questions that you have. So if you do, please jot some questions down, and I'm happy to answer those at the end of the briefing. Next slide. Okay, so let's start our organizational journey through Air Force Materiel Command. Obviously, AFMC is one of our Air Force major commands. Air Force Materiel Command is broken up into 6 centers. Think of a center like a numbered Air Force in the field. Most of them are commanded by a 3-star general or a civilian equivalent. And the two that we're really going to focus on today when we talk about sustainment are obviously the Air Force Sustainment Center that does sustainment logistics. But our partners in sustainment is the Life Cycle Management Center. And we can't do what we do to provide support for the field without a lot of folks in LCMC. Next slide. Okay, so what does AFSC look like at that numbered Air Force 3-star level? Obviously, we have our Commander, Lieutenant General Kirkland, and he has an Executive Director, Mr. D'Angelo. And there are 4 major operating locations for the Sustainment Center. You're probably familiar with the 3 major depots or air logistics complex at Oklahoma City, Ogden, and Warner Robins. And then Scott Air Force Base is where the supply chain operations wing is. So at the 3 major locations, in addition to the ALC, you also have an installation command, an air base wing, and those are commanded by colonels, and they are charged with functions like security forces, civil engineering, medical, force support. But what you need to understand about an air base wing at one of these 3 depots is the scale and scope of what goes on here. The number of facilities, the size of the operation, the amount of aircraft that come through it was to me when I first arrived almost incomprehensible. And so those 3 colonels are charged with quite a bit to make sure that the ALCs can run and carry out its day-to-day mission. Finally, you've got the 2 supply chain wings. There's the supply chain management wing here at Tinker, and then the supply chain operations wing up at Scott. And again, we'll go into each of those in a little bit more detail as we talk about how the Sustainment Center supports you in the field. Next slide. Okay, so let's go down another level, down to what the ALCs look like. You can see the 3 there, Ogden, Oklahoma City, and Warner Robins. The weapon systems are fairly unique to each base. As an example, Ogden focuses mostly on fighters, but they've also got ICBMs in as well. And they do some of our nation's C-130 work. Here at Oklahoma City, we do the bombers and tankers and a couple of special mission aircraft, AWACS, and the E-6 tactical aircraft for our Navy partners right here at Tinker. And then at Warner Robins, they're doing all of our large airlifters as well as the F-15s. Now, each of the 3 ALCs has a unique capability. They do landing gear at Ogden, engines at Oklahoma City, and they have a large electronics maintenance group at Warner Robins. Some commonalities, each of the 3 depots does ABDR, aircraft battle damage repair, and those are deployable military field units that will go out and get your aircraft that have been damaged in combat back into the air to fight another day. We also do commodities repair. So all of those parts that come off of the aircraft, think hydraulics components, life support components, those all get repaired, and there's a location for each of the 3. Now, I will say, and we'll talk a little bit about it in a few minutes, these are considered organic sources of repair, or what we do within the federal government. There's a lot of commodities repair that gets done by contractors. Those could be done right off base, certainly here at one of the 3 depots, or anywhere in Middle America. And the supply chain operations wing melds all those back together to present spare parts back to you at the time and place of need. Finally, there's a large and increasingly growing software maintenance mission, and you can see the types of software that they do. But all of that work is underpinned by the supply chain, both the Air Force supply chain and the Defense Logistics Agency, which is a joint organization. And you can see a number of functions that they do there. So those are what your 3 complexes kind of look like, contrasted from one another. If you go to the next slide, this is an example of what one of the 3 ALCs look like. I'm from Tinker, so I decided to show you the Oklahoma City ALC, commanded by a 1-star general, Brigadier General Jeff King, and his civilian deputy, Mr. Wade Wolf, and military deputy, Colonel Jeff Martin. There are 4 production groups here in Oklahoma City: aircraft, propulsion, commodities, and software. And there's also a maintenance support group. And think of a maintenance support group like your mission support group at the base, doing anything from facilities maintenance, upkeep, and modification, all the way to the the maintenance and repair of all of our test equipment, aircraft age type equipment, just kind of the handyman of the entire ALC. And certainly the place doesn't run without a maintenance support group. And then a full staff that you can see there across the right. Next slide, please. So ALCs are big. Strike that, they're huge. Until you get here and see the size of the facilities, it's really hard to comprehend. But you can see, for Oklahoma City, 33,000 indirect jobs, 10,000 employees here just within the ALC, the vast majority of which are government civilians. Now, this figure, 10,000, does not include any contractors that are working here in our midst, and there certainly are quite a few through some of our public-private partnerships. But this is just government workforce. And you can see the very small number of military. So those of us walking around in uniform certainly are in the minority. And then a large number of engineers as well, software engineers, but frankly, process engineers and structural engineers as well. As far as financials, it's a huge business. At the end of the briefing, I'm going to talk a little bit about the working capital fund and how ALCs and the supply chain are funded. But it is an impressive physical plant, 54 facilities at over 8 million square footage. I work here in building 3001, which up until a few years ago was the largest building in AFSC. Building 9001 was given to the government, sold to the government back about 20 years ago. It used to be a GM auto factory adjacent to the base. It was actually struck by a tornado, and GM was going through some downsizing at the time and just found that it was not financially feasible to repair that facility and bring it back online. So they sold it to the US government for a very small fee. We have now turned that into an enormous, incredible facility. They do everything from flight control overhaul to engine repair. And they have filled up every square foot of that. There's a forge in there, really just an impressive industrial facility. Building 3001 and 9001 are actually two of the 5 largest buildings within DoD. And we're blessed to have them here because, again, we filled up every square foot of that. And as the workload continues to increase here at Oklahoma City and really at all 3 of our depots, we're going to need all that space and even more into the future. Next slide, please. So we don't do it just organically. There's a lot of partners out there. I'm going to give a couple examples for you. So our industry partners, Pratt & Whitney, they're actually located here right in our midst. The Air Force has a contract, as an example, F-35 engines, the F-135 engine. There's a contract from the government to Pratt & Whitney to overhaul and sustain those engines. They have in turn let a subcontract to the propulsion maintenance group here at Oklahoma City ALC. And so you have blue suiters and contractors, and by blue suiters, I really mean civil servants, working side by side for the common goal of providing engine power back to the F-35 fleet. And the same can be said for our partners up at Oklahoma State and down south in Norman at the University of Oklahoma. We've struck up some academic partnerships with them where we actually have labs on both campuses, and then we have faculty and students that are embedded here in the depot, and we're able to really push forward on the use of technology, especially in software, and so those partnerships are really paying us dividends in the future as we grow the software enterprise, and it's a great source of recruiting as well. And we'll talk about some of the workforce challenges that we have for especially our engineers, and those partnerships with academia are really important. And then finally, we couldn't do it without close partnerships off base. The Oklahoma City, Midwest City, Del City, all the surrounding areas are just fantastic partnerships. And those are true both at Ogden and Warner Robins as well. And then internally to the government, we are one big team of teams. On the left, you see everyone in the here in the ALC. On the right side, you see partners from LCMC, the Lifecycle Management Center, as well as the supply chain. And without everybody working together, we can't return air power in the form of aircraft parts and engines back out to the field. So we're big on partnerships, and frankly, this place would grind to a halt if we weren't all working together towards common goals. Next slide. So just a snapshot here of what one ALC puts out in a given year. 9.3 million hours worth of labor hours. We put 199 aircraft back out in the field. That's both scheduled, programmed depot maintenance and also unscheduled depot maintenance back out into the field. 36,000 exchangeable commodities, and we have $84 million worth of partnerships. So there's a lot going on, and it is a big dollar value as well. Next slide. So I mentioned before a little bit about software. I was stationed at the Ogden Air Logistics Complex, which was actually a center at a time back in the early 2000s. There was a small group of software engineers, I would say probably about 100 or so, that were doing a little bit of software on the F-16. That workload organically within AFSC has grown tremendously over the last 20 years. So in this chart, you can see how each of those airframes, as they've come online, has increasing numbers of lines of software code. When I showed up, you told me that the new KC-46, which is, you know, a 2-engine tanker that goes around and fills up other airplanes with gas, would have nearly twice as many lines of code as an F-35. I wouldn't have believed you. But now understanding the mission of the KC-46 and its complexity and how it's planned for the future, it's unsurprising. And I'm also was surprised to understand how much of that software is developed and especially maintained and modified over time by our Air Force, civil servant, and military software engineers. So it's really an impressive organic capability. We're up to about 1,000 software engineers here at Oklahoma City, and the other two depots actually have even more engineers. I'll talk a little bit about the attempt to hire software engineers in a minute, but it is challenging. General Kirkland likes to say that if we hired every engineering graduate from the University of Oklahoma and Oklahoma State every year, it wouldn't be enough to feed the beast that is our requirement for growing workload. So especially the software group, but really the whole complex is out and about across the country, going to college job fairs, trying to hire the best and the brightest to come here to Oklahoma City. And I know the same is true with the other ALCs. Next slide, please. So let's talk a little bit about what the workforce looks like and some of the challenges we have associated with the workforce. For the first maybe 20 years of my career, this is what I pictured as a depot technician. Some crusty old guy that had been doing the same maintenance task on the same airplane for 30 or 40 years. I could not have been further off base. Next slide, please. This is really what it looks like. It's a young, diverse workforce. I have 4,500 folks that work here just in the aircraft maintenance group. Of that 4,500 personnel, 40% have less than 5 years of federal service. So it's not an old graying workforce. It is a young workforce. We have a lot of people who are new to government service that are in their 30s or 40s or sometimes even 50s that have decided to come and give this a try, maybe as a second career. But we've got two really major challenges that go along with that young workforce. The first is training. So I grew up in our active duty field level units where we have a very deliberate pipeline for delivering enlisted mechanics out to the field. Our airmen go through basic training. They go off to Shepherd for some kind of technical training. And that formal training process can be anywhere from 3 months all the way to a year. Then they show up for their first operational assignment. We put them right into a formal on-the-job and upgrade training where we spend another year or so to make them fully qualified 5 levels. And then later on, after more experiential training, we put them into a 7-level upgrade training. None of that exists here for our civilian workforce. In many cases, we are fortunate enough to hire folks that come in with an A&P license. maybe have a VOTEC program in their background. And certainly we like to hire veterans, but those are few and far between these days. And so unfortunately, we're then expected to still hire, and we go off the street and we're hiring people that many of whom have really no mechanical background whatsoever. But because we don't have a formal technical training pipeline, we give them an ID card, we show them how to log their time and attendance, and throw them right out on the floor and expect them to learn on the job. We're making some attempts at doing a better job of that in one of our squadrons, the largest here within the AMXG. We've actually created an in-house tech school, a VOTEC school, where we're taking those people that didn't come in much of a technical background, and we're giving them the basics in sheet metal, aircraft work, fuels, and not just in the art and science of doing those technical jobs, but also what does it mean to be a professional maintainer? Using tech data, FOD control, wearing the correct PPE, all those things to try to turn out a better employee, a better airman out onto the floor. Some of those initiatives won't bear fruit for a while, but it's a good step in the right direction. The other major challenge we have with our workforce, especially contrasted to what we have in the field, is there's really no supervisory development program. So again, comparing to what we know in the field, airmen come in, they learn their jobs. After a few years, they get promoted to staff sergeant. We send them off to Airman Leadership School. They learn the art of leading a small team. And after they've done that for a few years, they work their way through the ranks, and we send them back to the NCO Academy and eventually to the Senior NCO Academy. There's nothing like that for our civilians. We basically just say, hey, you're a good mechanic. I'm going to make you a supervisor of 10 or 20 mechanics. And unfortunately, we don't do a great job of providing them deliberate education and training in how to be an effective supervisor and leader. Again, many of us across AFSC are making a better attempt at that. In my own group, we've created a 2-day training seminar to teach them both some hard skills like how to do disciplinary work, how to fill out time and attendance sheets, kind of to keep the trains running, but also the soft skills of how to have difficult conversations with an employee, how to look for signs of trouble, how to motivate people in a positive manner. We've got some pretty good feedback on those classes. Air Force Materiel Command has actually just rolled out a new program for us in a similar vein. And so I think the need is obvious, and in many ways, AFMC is reaching out and understanding that if we want the most out of our employees, we have to give them some good leadership, and supervisory development is a challenge of that. And I'll finish talking about recruiting and retention, the challenges we have there. As I've talked about before, we like to get folks with a technical background. We are not always successful in doing that, but we want to keep them for the long term as well. So we're hitting job fairs, and there's one ask that I can make of you. So if I could bend your ear for just a moment and ask a favor. If you're ever counseling one of your airmen, maybe coming up on the end of their first or even second enlistment, and they say, hey, ma'am, hey, sir, I really enjoy what I do. I like working on airplanes, but I'm not sure the Air Force is for me. I don't like having to cut my hair a certain way. I don't like wearing a uniform. I feel bad uprooting my family every couple of years for PCSs, or I'm gone too often on deployments, but I still really like the work that I do. Maybe suggest that they consider coming to work for the Air Force as a civilian, one of the 3 air logistics complexes. Let me tell you why. First, the pay and benefits are pretty good. They are probably not quite as good as working for a private firm. As an example, my IMA actually works up at Tulsa for American Airlines at their large MRO facility. And they do pay just a little bit better, but I'll tell you, there's something to be said for stability as well. As we entered the COVID pandemic last year, you know what that did to the commercial aviation market. And unfortunately, a lot of our partners out there in commercial aviation have had massive layoffs. And my IMA and their folks up there were certainly not immune to that. Here at Ogden, or here at Oklahoma City ALC, just the opposite. Not only have we kept everyone at work at their jobs, we've continued to hire as our workload has increased, and so it's a stable job. The other great thing about this, getting to continue on, one, serving your nation, but doing it in some pretty nice locations. I've been pleasantly surprised at how nice Oklahoma City has been. There's art, culture, sports, restaurants, bars, great places to travel just in a short radius, and it's a nice family town. And I know from personal experience that Salt Lake City, Utah, and Middle Georgia are the exact same way. So again, if you have an airman that just likes being around airplanes and likes what they do, but maybe has decided that the Air Force active duty reserve guard is just not for them, send them our way. Hit up usajobs.com and they can easily find their way to looking for a job here. All right, next slide, please. So that's what we do. I'd really like to spend just a couple of minutes telling you how we do it. And the reason I think that that's important is because some of these concepts are coming your way. And I want to tell you how successful they've been here in the depot over the last 10 to 15 years. You may be familiar with the term Art of the Possible. That is Air Force Sustainment Systems Management System. It's a system based on theory of constraints and continuous process improvement. You may have heard of theory of constraints. If you haven't, you're going to soon. It has worked well here in the depot, and the Air Force is sending it out across the fleet. Theory of constraints was started here specifically at Oklahoma City ALC about 12 years ago, and it's not an old science, but certainly well established in private industry. If you'd like to learn more about theory of constraints, I'd like to recommend a book called The Goal by Eli Goldratt. Great book that really helps you understand where to focus your efforts. In fact, if I could make you a further recommendation, don't read the book, listen to the book on tape. It's a great fiction story, but it's really a nonfiction message that teaches you where to look for problems. And again, I mentioned the second part of Art of the Possible is continuous process improvement. So leading up to my assignment here at Oklahoma City and in the Air Force Sustainment Center, I was a big believer in process improvement, and I used tools like 8 steps, but I didn't apply them in the right place. When you understand theory of constraints, you understand that all work is a process, and that at some point where you have a bottleneck, work will build up. And that's where you need to spend your time and energy from a continuous process improvement perspective. And so what they have been able to do here, specifically at Oklahoma City, and as an example, I'll use our KC-135 PDM line. And that was kind of really the birth of Art of the Possible. Back in the late 2000s, there were 54 aircraft at a time here on the ramp. And each 135 PDM took in excess of 450 days to complete. So think about that. That's more than a year away from the flight line. And in a 5-year cycle, that's really a large percentage of its time spent at the depot. Fast forward 12 years or so, and through the use of Art of the Possible, theory of constraints, and our standard Air Force CPI tools, they have gotten that down to 120 days on average to send a 135 back to the fleet. And instead of 54 aircraft being on station, today I've got 28 aircraft here on the KC-135 PDM line. So that means almost half as many aircraft here, and the remainder are back out in the field doing what they're supposed to be doing for our warfighter. In addition to that, we've been able to do an increasing amount of workload, and I'll show that on a chart coming up. And we've done it in an increasing quality manner. And so I'm really impressed with the culture here of continuous process improvement. I've never seen it throughout the 24 years in the Air Force anywhere better than in Air Force Sustainment Center. And so Yes, I'm bragging a little bit, but what I want to do is motivate you to understand the power of theory of constraints. And so eventually you'll start to see that in training. You may see that in your initial skills training, intermediate skills training. Amos is working it into their curriculum, eventually into PME. It's starting in maintenance. It'll spread to all of our logistics functions. And my hope is that eventually it spreads throughout the Air Force. One of the key parts, and you can see there, the last bullet, is our enterprise partnerships. We don't do Art of the Possible alone, just within AFSC. We make sure that our partners in the supply chain, in DLA, in the program offices, that we're all focused on the common goal. And that common goal is returning safe, reliable aircraft back out to the warfighter. Just a couple quick plugs for things that have worked well here within Oklahoma City. One of them is concurrency of work. What I mean by concurrency of work is in the old days, we used to bring an aircraft in. We would do major structural repairs. You do one at a time. You'd do a repair that might take you 5 to 7 days. You'd wrap it up. You'd pulse it to the next station. You'd do another structural repair that might take you another 5 to 7 days. Pulse it down to the next station, so on and so on. Now, in working in close concert with the program office and their structural engineers, we figured out ways to layer that work on top of each other. So now I can do all 3, or in some cases, 5 or 6 structural repairs simultaneously. I can man load those aircraft and work simultaneously, slashing the number of flow days that it takes us to do a PDM and getting the aircraft back out to the field much more quickly. In another way, we do kitting. If you're not familiar with kitting, it's creating simply a box with everything that the mechanic needs to do their job and making sure that it's there. We like to treat our mechanics like surgeons. We want them to have the right tools, tech data, equipment, and piece parts there at the place of execution, and avoid hunting and gathering throughout these very large buildings. In the old days, a mechanic would show up for work, find out what task they were doing for the day, and immediately set off hunting around the building for all the supplies, tools, and piece parts they needed to put that aircraft back together. Now, we've dedicated whole shops of our employees that spend their full-time job putting kits with all those items together, and then it's delivered to the mechanic right when they need it. And the mechanic does the function, cleans up their work, gets ready for the next task, turns to the other direction, and the next kit is ready there for them. Now you're saying, Greg, I could do that if I was in the depot and had the large number of employees that you have and had a working capital fund to pay for those employees. But what I'll tell you is it's applicable everywhere. It's an investment in your own productivity. It's an investment in your own efficiency. So by grouping those items together and providing for mechanics, it drastically increases the amount of time that we can have our mechanics working on aircraft and not spend time hunting and gathering the things they need to do the job. And so I look forward to the opportunities where we can employ that out in the field as well. So again, I just wanted to share some of the things that I think are successful here, share them with you because I know many of these initiatives are rolling out into the field, but I'll leave this slide with one thought for you. The success here at Oklahoma City and really throughout the Air Force Sustainment Center is not these individual tools. I personally believe that it's the culture that has embedded within the workforce here. That culture is so strong that if in the future, I personally believe, if in the future General Kirkland were to move on and a new AFSC commander were to arrive and say, you know what, this Art of the Possible things for the birds, we're going to try something new. I truly believe that that Art of the Possible would continue on below the surface because the employees here have lived it. They have been on the journey and they have seen firsthand the drastic improvements that it has created for Oklahoma City and certainly our partners out at Robbins and Hill. I ask you to give some of these things like theory of constraints a chance, lean into it, understand it, believe in the culture, learn about them at the various places you have the opportunity to do so. And eventually we need to get to the point where when Lieutenant Smith or Airman Jones learns about theory of constraints at McConnell Air Force Base, and then PCS is to Mildenhall, theory of constraints looks the same way at both bases. And we build upon those. So eventually Colonel Smith and Lieutenant Jones or Chief Jones are seeing the fruits of their labor over many years and the drastic improvements over time. We've got to get more efficient as the workforce of the number of airmen doing logistics functions stays the same, and our workload increases over time as our aircraft continue to age. So that's my pitch. Next slide, please. So this is what a KC-135 PDM looks like, and I only show you this as an example of how we bin work into gates. Most of the machines, the production machines here at Oklahoma City have 5 gates, and that's what they are binned up into. Frankly, the most important part of what we do is in the inspection dock. It's understanding the condition of the aircraft before it rolls into gate 3, structures and buildup. That's where we really do the intense work of structural repair on all these aging platforms. Again, for the KC-135, it takes just a little over 120 days from start to finish. Some of our more complex platforms like the E3 AWACS can take considerably more time. But we're always working to reduce the number of flow days while keeping our quality the same or frankly getting even better. Next slide, please. So this is a great chart that shows you what happens as our aircraft get older. You can see fiscal year 14 through the fiscal year that we just finished. And that black line that's increasing from left to right, that's the number of major structural repairs per aircraft. These are spar changes, trunnion changes, things you would never comprehend or even attempt to do in the field. And that number of MSRs, or major structural repairs, it's indicative of the number of hours that we spend on each aircraft. But because we're able to do a lot of that work concurrently now, the kind of dark blue line, or our flow days, has remained pretty consistent over time. And so we're able to do an increasing amount of workload and return the aircraft back out in the same amount of time. Now, we do that selfishly as well, because by keeping the aircraft here for a shorter amount of time, it increases the capacity here in the physical plant at the ALC and allows us to do more workload here into the future. So that's what it looks like as our fleet gets older. Greg Lowe's guess is that in the future, that black line will continue to increase. So the workload will increase, and we have to find ways to efficiently return aircraft back out to the field. Next slide. Okay, I'm going to shift from aircraft work over to parts. This is what I thought as a field maintainer. I thought parts were being hoarded by the depot. I thought they were all in some big government warehouse like you can see on the bottom left, perhaps sitting right next to the Ark of the Covenant. I could not have been further from the truth. If you'll advance the slide here, a couple of notches, one more, and one more. This is what it looks like. The shelves are pretty empty here too. Now, what that means is that our supply chain is very efficient. When you take a bad part off your aircraft at base X, it's immediately shipped back to a source of repair. That might be here in an organic depot. That might be in a depot contract facility. Again, here close to a depot or anywhere across America. Once it's repaired, it's immediately shipped back to a point of need and then very quickly put back onto an aircraft. Now that efficiency comes at a cost. As we begin to think about operations, ACE operations, how do we send those spare parts? How do we know where to send them in advance? And how do we do it to more operating locations than we have today? That's the challenge that we as logisticians really have, is understanding how to take our today's very efficient supply system and adapt it to an ACE environment. That's what we're working on now. Next slide. So I mentioned at the beginning that in addition to the 3 ALCs or depots within Air Force Sustainment Center, there's also 2 supply wings. this is where I get the opportunity to kind of show you what they do and why they're different. Let's start on the left, supply chain management wing. It's headquartered here at Tinker, and they do what's called wholesale supply chain management. And they're thinking about weapons system availability. How do we make sure that we can maximize in an efficient and cost-effective manner? How can we maximize aircraft availability throughout the fleet? And they do that through planning and executing spares requirements, reparable spares requirements. So these are, think your item managers. They are looking in the past at supply demand, and they're gonculating that with future demand requirements based on flying hours to figure out how many spares need to be bought new or repaired to meet that future demand. Now, it's not an exact science. We all know that. We've all been waiting a single hit MICAP out in the field, and there are none available worldwide. But when you think about an item manager that might manage anywhere from 1,000 to up to 2,000 or 3,000 different parts, they're really balancing a lot of different issues. And of course, you all know that we are increasingly faced with diminishing sources of manufacture and repair. So think old parts that the original equipment manufacturer may have gone out of business, or frankly, they're just such a small order quantity that nobody out there wants to repair the parts. And so a lot of that falls on the organic to figure out how to do that in as cost-efficient manner as possible, knowing that we still have to keep our aging airframes in the air. Let's switch over now to the supply chain operations wing. They're headquartered up at Scott, and that is a retail supply operation. So when you think about the difference between retail and wholesale, think about going to a retail store, Walmart, Target, your local grocery store. They're the ones that you as a customer really interface with. And it's no different for you as a maintenance or an LRS outfit in the field. The supply chain operations wing, or your appropriate supply chain operations squadron for your MDS, is your interface with the supply chain. And they are also making sure that they move parts around. It's really a big command and control function to move parts around to the right place at the right time, anticipating where the next demand will be. Now, in addition to doing all the spare parts command and control function, they do a whole bunch of other neat, pretty unique stuff like war reserve material. Where is it placed? Why is it placed there? And if it's not at the right place where we need it, how do we get it there as quickly as possible? They manage all of our vehicles and equipment. They manage energy for the Air Force. They do all of our bear assets. If you've ever been deployed, lived and worked in Tent City, the bear team, as part of the SCOW, is running that for us. They know where all the mobility bags are. And again, positive inventory control for our nuclear weapons related material, kind of an undersung but incredibly critical function for our nuclear forces. Okay, so I've talked a little bit about the difference between supply chain management and supply chain operations. Let's go on to the next slide. Let's talk about the next slide, please. Thank you. Let's talk about the Lifecycle Management Center. This is the other center within AFMC that provides sustainment for us. If you'll go on to the next slide, this shows you what the LCMC looks like across our country. They're organized by function. So there's a program executive officer, or PEO, for functions like agile combat support, fighters, bombers, presidential and executive airlift fleets. And within each of those functions, there's a system program office for each MDS or end item. So think F-15 SPO, B-52 SPO, executive airlift SPO. And those system program offices, they manage the cradle to grave life cycle of all of our items. Cradle, they're planning for and purchasing new equipment. Think KC-46, B-21. They're working on modifications to upgrade current systems. So think re-engining or putting new avionics on legacy B-52. They're doing sustaining engineering for all of us. So as you come across a break on your aircraft, and man, we use them all the time here in the depot, things that are beyond what the tech data gives us allowances to do, those sustainment engineers are crafting up what a proper repair looks like. And then they do the grave portion as well. And so in this manner, think very recently, we are in the midst of retiring 17 B1s. So how do we plan for that accurately and get them into the boneyard, the Aircraft Maintenance and Regeneration Center, AMARG, out at Davis-Monthan? How do we do and manage a platform from cradle to grave? It's our partners in LCMC, and we couldn't do it without them. Okay, next slide, please. The last thing I want to talk about is the financial underpinnings for all of this. So I grew up in the field, and as a squadron commander, as an example, the comptroller gave me a sack of money and said, Greg, here you go. You need to spend this sack of money before the end of the fiscal year. And oh, by the way, if you don't spend it all, I'm not going to give you as much next year. Now, we know that's not true today, but realistically, you're given a fixed amount of money to do all of your functions throughout the year. And it's up to us as commanders to prioritize what those expenditures are. Here in the Air Force Sustainment Center, we operate under the concept of a working capital fund. It's money in and money out. Take the example of the B-52 fleet. There are two main operating locations, and they are funded for sustainment. The money for that sustainment goes to the B-52 program office, and that money then comes to me, again, in a sack for a number of PDMs throughout the year. And it costs a certain amount of money to do each PDM. And I charge my customer, this B-52 program office, a set amount of money. Then I take that money and I spend it out. I spend it on labor costs. I spend it on energy. I spend it on facility upkeep and modernization. And I spend it on the spare parts and material that I need to rebuild a B-52 every 4 years. And so that money comes in, the money goes out, money goes into the supply chain, into the supply working capital fund as we pull parts off of the shelf, just like you do in the field. But that working capital fund is designed to keep us as efficient as possible. I won't go into too many details. It's very complex. I'll be honest with you. I don't even understand it completely. It can take an entire career for some of our FM professionals. But I encourage you as a growing logistician to really understand that where the money flows, where the power flows, and that's how we sustain our aircraft. So begin to understand about how these working capital funds work. Okay, let's go on to the next slide. I've kind of wrapped it up here. I talked mostly organizationally, but what I really want to leave you with, it's not about organizations, it's about teams and teams of teams working together for a common goal. And the common goal in Air Force Sustainment Center is ensuring that our nation's fleet of aircraft and systems is viable now and into the future. So again, I'm blessed to have been here for a very unique assignment. I am so proud of the airmen, both uniformed and civilian employees here within the 76 Aircraft Maintenance Group and across AFSC and our partners in LCMC. Their drive for putting combat air power back into to the field is unmatched, and we're very proud of what we do. So I'm going to stop there, and thank you again for watching the video. I hope you enjoy the tour, and I'm standing by for questions.